now. All right, so this is our lesson 8 presentation of what we've learned so far in the class. Chris Bolschweiler, Justin Lee, and Aaron Daines are the group members. We first want to talk about how to develop a method and list the 7 steps. Step 1, we want to clearly define the problem. Step 2, we want to create the test matrix. Step 3, we want to outline the solution. Step 4, we want to test the algorithm to make sure it runs correctly, or to make sure we have all of the information there that we're wanting to test. Step 5 is where we translate the algorithm into code. Step 6, run the test cases to verify that the code is working as specified. For our previous assignments in the class, we've ran 5 or 6 test cases for each method that we created, just to ensure that it runs correctly. And step 7, we want to finalize our changes and deploy the changes to our repository so that our group has access to them. This slide here goes over a couple of those points. This is an example from our lesson 5 assignment. First thing we always do is we state the problem to be solved. And our plant crops method here, this is our example. We want to find the method to allocate seed for the next year's crops. So up at the top here, we have our test matrix. We have valid and invalid numbers. In the middle here, we have our output that could, we have our test matrix here, then those numbers could change. And then at the bottom here, we have, this is what our output will be expected to be.
All right, and then on this one, we've got the code that we're actually testing. So for this, it's going to be the plant crops case 1. So we have the crop data reference, and then we set the wheat in store value at 500, and this is dependent upon the test matrix we were just looking at. So set the wheat in store at 500, set acres owned at 1,000, set the population at 100, and so on, down to our expected result is 500, and that's based on the calculations that are set up there. So those values will change depending upon which part of our test matrix we're testing. If we're testing a valid calculation, or it's going to be the boundary, or whichever one we're testing, so we can change those values.
Okay, next slide. We just detailed briefly the 3 types of selection statements in Java. First, we have the if statement, which is fairly simple to explain and understand. It either performs or selects one action if a condition is true, or skips it if the condition that we state is false.
Then we have the if-else statement, which performs an action if a condition is true, and performs a different action if the condition is false.
And then the third one we have for the selection statements is the switch statements. This one's useful when you need to select one of several alternatives based on the value of an integer, character, or a string variable.
A little bit more in depth, here's an example of a if statement in Java. So first we have our comment, which states what we want to, states what our code, what we want it to do. So if set aside wheat is less than 0, it returns -1. And then we have the actual code where it performs the code that we want. So if set aside wheat, if the value of that is below 0, it returns a -1.
Then we'll have the if then else Java statement a little more in depth. So this one says basically if you have a number that is less than 0, it'll put out a positive number. Else, it will give a negative number if it is less than or greater than 0.
And with the switch statement, I think this one's pretty cool. It's definitely useful when you have a lot of different options. You don't have to do an if else, all the way down. So you do the switch, and then we have our case 1. start new game, and then case 2, start saved game, and so forth. So if we're selecting, for instance, 5, then it's going to output thanks for playing, goodbye. And it depends on what input is put in there for this, in this specific case. So the break, if it's not, like for instance, for case 2, if we put in a 3, it's going through this code, it gets to case 2, it's not a 3, so it keeps going, the break makes it go to the next one, and so forth until it matches.
Okay, so then we get into our individual assignments that we made. And so this is the plant crops portion, which I have made. So basically what this is telling you is based off the matrix that we made earlier, we're setting variables and getting an output. So on this one, we set our wheat in store to 500, our acres owned as 1,000, and we're expecting a value of 500. And so it's important that we have our test values so that we can make sure that we're continuing to make sure that our code is working properly.
Okay, this here is the unit testing for the feed people method that I created. We have those variables that are set. We have, depending on which matrix we're testing, we have the needed number of bushels. Right now we have that set to 0. We have our remaining wheat, which is 0. We have our set aside wheat. We have that set at 10. We have our crop data, our variable defined there. And we have our set wheat in store at 30. And the expected result is 10, depending on those variables that we have listed above. That will change the expected result depending on which part of that matrix we're testing. And then the result is displayed to us.
All right, then this is the one that I created, the set offering method. So with this one, with this specific test case, one that we have here, so we've got wheat harvested set at 50%, offering set at 10, and expected result is 10. And those values is we would change along with all these other test cases. You change those values to test your code to make sure that it's that the calculations are correct, that the values that you're putting in are calculating correctly and giving you the expected result. And also, if there's things that are supposed to be invalid, that it's calculating those as invalid. So the unit testing is definitely important that way.
And next, we briefly explain the scope and lifespan of a variable. Here we have an example from our code that we created in the class. So the scope of the variable is defined in the get menu option. And the lifespan will last until the end of this code here. So it's defined up at the top where get menu option, integer user input, that's where we define our scope and we define our variable, and the lifespan the end of the lifespan will be at the end of the code after everything is calculated and we get the value returned to us.
So next we're going to go over the passing of parameters by value and reference. So on this one, we have in this plant crops view method, down a little bit below the crop control plant crops, acres to plant and crop data. So passing by value, those values of acres to plant and crop data will be able, the value of those variables can be passed to other parts of our code. So both pass by value and pass by reference allow us to pass things in different parts of our code in different ways, and that's kind of how pass by value works.
And then pass by reference, we have these are set objects that are passed. So in this case, we have acres per bushel, which is a set object, set number, and so they're locations of the object in memory and pass. So it's kind of like the pass by value, but this one is a reference that's stored in memory. And so it's important that we have these to keep there because we don't want them changing on us.
And that concludes our presentation for Lesson 8, briefly detailing what we learned in the course so far. Okay, I think